Osiyo! My name is Susanna, aka Disesdi, and I am the AI architect at mlops.archi. So what does it mean to be an artificial intelligence architect? It means that I lead data research and manage data teams. I act as a bridge between infrastructure engineers, machine learning engineers, data scientists, and other team members and stakeholders. I lead product development, and I'm responsible for our overall data posture. And I report directly to the C-suite. I have experience in multiple positions in the data stack. I've worked as a data scientist, a data engineer, machine learning engineer, and prior to this, I was a security researcher, offensive security engineer, and red team lead. So the intersections of artificial intelligence and security are my primary research focus and interest. That's what I'm into and what I could talk about at length. So why did I decide to make this video? I wanted to counter an issue that I was seeing, which is there's a lot of hype right now in the news cycle around AI, and from the perspective of an actual engineer that's working in this field, very little of it has anything to do with real artificial intelligence engineering or what we're actually building or the issues that we're actually facing. So I wanted to see if maybe it would be possible to bring these issues into the public consciousness a little bit, because we have a lot of people talking about AI doomsday scenarios and terrible things that might happen, and AI achieving intelligence beyond humans and sentience and all this. And this isn't really reflective of the reality of what we do, and it isn't really reflective of the actual potential safety pitfalls that we face when we're building real-life production AI applications. So that's what I want to talk about here. Actual real-life engineering, not AGI, not AI doomsday scenarios. Maybe it's not Skynet exciting, but it is what we really do on a daily basis as artificial intelligence engineers. So countering hype with reality, how? Well, I wanted to talk about the real elements and issues that are happening in real production AI. I'm not really so much a fan of calling out the negative and arguing about that. I'd rather focus on the things that I would like to draw people's attention to. So there are a number of actual issues in production AI that really matter and that more people in the general public, I think, should be aware of. So I'd like to kind of demystify that a little bit and maybe take a little bit of the fear and the hype out of it and reduce the intimidation factor in terms of understanding AI if I can. And if I do that at all here, I will feel that I've been successful. Okay, so first of all, what do I mean by production AI? I mean the real AI that engineers are designing and building and that you are probably interacting with as a consumer every single day. It's actually got a lot of moving parts and pieces, including roles like data scientists, data engineers, machine learning engineers, which are all kind of siloed and separate in certain ways from other aspects of building the app and maintaining the app. So there are kind of a lot of moving parts and pieces. You also have to think about your software components and your overall security stance. And this becomes particularly important when you're building for safety critical applications like aerospace and defense, or when you're working with particularly sensitive data, like for a health application like what my team is building. So as you can see, there's kind of a lot going on there, and I think it would probably benefit the general public and the data conversation in general if more people were aware of some of the real things that are going on under the hood. So what are these issues? I can give you a few of them really quickly because I don't want to take up too much of your time. If I can just put into your brain a few, whether you're a C-suite individual at a startup or just a total non-tech, non-engineer person that wants to understand AI a little bit better. Let me just give you a few little tidbits to think about that I wish more people would be aware of in the field of artificial intelligence. So number one thing that you may not know about AI is that every single model, no matter how big or complex or cool, works on the principle of data in, predictions out. And this is the case even for generative AI, such as large language models like your ChatGPT that a lot of people are excited about interacting with. It takes data in and it predicts what the next word will be in a sentence, for example. So if we think about how much data is required to train these models, it's actually totally massive amount. and the gains that we've seen in performance, where you can now kind of have a conversation with ChatGPT, or maybe you shouldn't do this, but get it to write an essay for you. Those advances are because we have the ability to take in massive amounts of data, as well as the compute power to train these models, although that's not necessarily distributed evenly in industry. Not everybody has access to that. But massive amounts of training data are needed to train these to make them work. The problem that you may not know about, unless you're in this field, is that we're slated to run out of data. Some estimates are saying as early as 2026, meaning that there won't be any new data to train these models on, because they are intaking data faster than human beings can put it out. So think about that for a minute. If we take all of the human output over the next couple of years, it's still not going to be enough to continue training these models at the rate that we're projected to need the data. What are we going to do when the data runs out? There are some proposals on the table. Some of them are a little bit wild, but one that people are talking about that's popular is synthesizing data, which is just kind of a sophisticated way of making stuff up and hoping that it reflects reality pretty truly. And it's good, but there are some mathematical hurdles to that, and some practical hurdles as well. And it may not necessarily be a viable solution, because made-up data may not be good enough to train models on. Only time will tell, and we'll have to see if we continue to need data at the current rate. Another thing I wish for everyone to think about, and something that's near and dear to my heart, what about the hurdles of actually getting models into production? A secret that you may not know if you're not in tech, or even if you are in tech but you're not in AI, it actually takes very little code to create a pretty good model. Recently, I created a model for our team that got 80% accuracy out of the box on the data set, and then with refinement, we were able to get it well up over 90%. And secret was good data cleaning and feature engineering. The model itself, the algorithm, was maybe under 20 lines of code. The secret sauce, if you will, was in getting the data ready and understanding our data and taking the time to really dig in and see what was going on with it. So the model itself wasn't that hard. If you go to TensorFlow's website, you can read the documentation. TensorFlow is a library that allows machine learning engineers to implement deep learning neural nets with relatively little code. You can go check and see exactly how to make a neural net using TensorFlow, a basic one, and it's shockingly little code. What this code doesn't do is the big deal, though. What this code doesn't do is get your model into production. It isn't going to ensure that your model can be served to hundreds of thousands or potentially millions of users at scale in real time, potentially. It doesn't make sure that your model is making correct inference over time. It doesn't monitor to make sure that you aren't losing your model performance due to things like concept drift, schema drift, and data drift. What this means is that even if you start with reasonably good data, and if you work really hard and get a really good model out of it, you still have a number of hurdles that you have to get over to actually get this model into production and into people's hands. And along the way, you have numerous pitfalls that can be introduced in terms of your data security, in terms of data privacy, the security of your models and overall organization. So there are a number of things that can go wrong that have absolutely nothing to do with either science fiction, doomsday events, or coding the perfect algorithm. Okay, that's a lot, and I could go on. I actually had more stuff written, but I'm watching the time for this video go up. So I'm going to leave you with this, my motivation for finally getting over my fears and my nervousness and making this video. Native American Heritage Month. As a Native engineer, I am super proud to be talking to you today. I'm super delighted to be in the field that I love. And I just wanted to tell you about one of my heroes, Mary Golder Ross, who was the first known female Native American engineer, the first female engineer at Lockheed, the only female founding member of the ultra-elite Lockheed Skunk Works, and a founding member of the Society of Women Engineers. She was interviewed about her education. She talked about being asked what she wanted to major in when she first went to college, and she didn't know what a major was. And I felt that because Sometimes it's easy to feel like an outsider. If you feel like an outsider wherever you are, maybe you're wanting to learn about artificial intelligence, but you're feeling a little bit intimidated by it, I hope you can remember that Mary Golda Ross was the only Native American and the only female in the room in Lockheed way back in the day, decades ago. And she held her head up high and let the elegance and the technical accuracy and the innovation of her work shine through. If I can do anything to demystify artificial intelligence, bring some of the real issues into the public conversation, or maybe help someone out there feel a little bit less like an outsider in the field, then I'll be pretty stoked about my results here with this video. Okay, thanks. I think by the rules of the internet, I am contractually obligated to ask you that if you got something out of this video, if you could like it, smash the like button, or subscribe. I would totally appreciate it, because if people like this, I'm gonna try to make more videos talking about the real issues in AI. Okay, until next time, take care.